Silica is used in many forms like silica sand, microsilica, or silica fume, precipitated silica, fumed silica, etc. They have variety of applications as fillers in coatings, then screeds, mortars, and concrete aggregate. And some of them are used in cement replacement in high performance concrete, and it is also used as a densifier in coatings. Then some of the precipitated silica they are applied in as matting agent and anti-settling agent, so that it has got some thixotropic control in the paints and coatings. So it's a very good rheological modifier, and this will be useful for arresting the sagging in paints or coatings, that is anti-sag agent. And this is also very good hydrophobic. Sometimes the hydrophilic grades are also available. So likewise, we have got a variety of silica. So I would like to throw some insight on this topic, the differences among the silica, the different types of silica uh, we are using in industries. Now, let us see the first one, that is silica sand. Usually its size will be 200 to 300 mesh. In terms of microns, it can be between 75 and 38 microns. So the basic formula is nothing but silicon dioxide, that is SiO2. The main characteristics of silica, that is this silica sand, it is a crystalline quartz, then it is coarse, and it is inert. It is not chemically reactive, so it is a inert chemical. Then it's used as a hard filler also. So that is why this silica sand is used in coatings as fillers, and it's also used in screeds, mortars, and in concrete, any concrete aggregate. Now let me move to the microsilica. So what do you mean by this microsilica? So this is also called the silica fume, and its micron size will be in the order of zero point 0.1 to zero point 0.3. That is its micron size, that is zero point 0.1 micron to particle size is zero point 0.1 micron to zero point 0.3 micron. And this is called an amorphous silica. And the main characteristics of this microsilica are it is ultra fine, then it has got a very high surface area, because finer the particle size, greater will be the surface area. Let me explain about this pozzolanic reaction. This pozzolanic reaction consists of actually three stages. In the first stage, the calcium ion as a Ca2 plus is separated from calcium hydroxide. So calcium hydroxide is ionized into calcium 2 plus and 2 hydroxyl anion. So this results in very high pH, say about a pH around 12 to 13. With this high pH, now this silicon dioxide can react to form, that is this orthosilicic acid type of reagents. So here you have got H2SiO4 2 minus with the release of a 2 hydrogen plus. Now, this H2SiO4 2 minus, that silicate orthosilicate, can react with the calcium so that you are able to get the calcium silicate hydrate bonding. So this is generally represented as CSH bonding. Now, actually, that is when you've got this that is aluminum hydrate along with the Portland cements, you are able to get different types of these CSH bonding arrangement. For example, from cement hydration, you can get a CSH, and from pozzolanic reaction, you are able to get this kind of a CSH and CAH. A represents for aluminum. Now, let me explain about the differences of this pozzolanic reaction and the cement setting, because most of the people they get confused with the cement setting. So cement setting is entirely a different phenomenon. So it is different from pozzolanic reaction. So let me explain one by one. For example, that is when we attempt to define what cement setting is. This is nothing but hydration. That is chemical reaction of cement with water. So that is called the hydration of cement, where the cement is hardened. But in the case of a pozzolanic reaction, this reaction takes place, that is, this reaction of a pozzolans with the calcium hydroxide in the presence of water. So this is something different. This results in CSH type of bonding. Now the primary reactants of cements are here the uh, carbon sulfur compounds with the three elements of three moles of carbon like C2S, C3A. A represents the aluminum or alumina, that is aluminum oxide. And here it can be of a C4AF also. So likewise, these are all the hydrated products. Whereas pozzolanic reactions, here the primary reactants are siliceous material or siliceous material means a silicon-based material or aluminous material, like in the case of a microsilica. So that reacts with the calcium hydroxide and water. And that results either CSH type of bonding in absence of alumina. In presence of alumina, it results in CaH. A represents here alumina. So this is forming a cementitious gel in the case of a pozzolanic reaction. And the main products are here, that is CSH, that is calcium, silica, and hydrate compound. And calcium hydroxide is also formed. Along with that, you have got this etringite type. Then you have this CSH and the CAH in the case of that is a pozzolanic gel, reaction. And in the case of, let us consider the speed of the reaction. Actually, cement setting is fast. It starts within minutes, significant hours. It starts within minutes. Whereas the pozzolanic reaction is slow. It starts after certain hours and it can even continue for a week or 2 months. So it is a slow and steady process. And when we discuss about the function of these two types of reaction, that is cement setting and the pozzolanic reaction, cement setting is setting quickly and it hardens into a paste form, that is cement paste. Whereas this kind of that is pozzolanic reaction, this enhances long-term strength and durability. So the heat is generated in the case of cement setting, whereas in the case of that is pozzolanic reaction. It is very, mildly exothermic, but this is almost negligible. Then, when we talk about the contribution to the strength, this can achieve the strength within 0 to 7 days, whereas the later strength, that is, the strength is going on picking up from 7 days to 90 days and even beyond. So the dependency is it occurs independently with water, whereas it depends on calcium hydroxide from cement hydration. So let me summarize this part because this pozzolanic reaction is very important. So cement setting is the initial chemical reaction. It's only a hydration, and that causes the mixture to stiffen further in order to gain the strength. Whereas a pozzolanic reaction is a secondary reaction and that consumes excess calcium hydroxide and contributes a long-term strength and it gives you a very good water resistance and durability. Then it is a very good cement replacement in high performance concrete and this is also used as a densifier in coatings. Then regarding precipitated silica, so this has the micron size from 5 to 40 microns. It has got variable grades, and based on the particle size, they are available in the market. And this is also categorized under amorphous silica. Now, let me explain about the main characteristics of this kind of precipitated silica. So here, it is a synthetic. This type of precipitated silica is a synthetic one, and it is porous. So that is why it can act as a matting agent. And since it is porous, it has got it has got a low bulk density, and it has got high oil absorption. So it will give a mattening effect, that's matte effect, and it is used as a thixotropic agent. That is, it is capable of controlling the thixotropicity of paints and coatings, and it is used as an anti-settling agent also, so that you can avoid the settling problem with any kind of paints and coatings. Then, regarding the fumed silica, so the micron size of such type of fumed silica lies between 0.01 and 0.05. It is much more finer, very, very finer. So it is in the order of nanoscale, that is nanometer. Nanometer means a 10 power minus 9 meter. Micron means a 10 power minus 6 meter. So the particle size is very, very fine. So it is in the order of nanometer, so 10 to 50 nanometer. And this is also an amorphous type of amorphous means non-crystalline. It is not a crystal one, non-crystalline. Whereas a regular silica sand is a normal crystalline one. But starting from the grade micro silica, precipitated silica, fumed silica, these are all amorphous, that is non-crystalline silica. So it has got a very highly dispersing nature, and it is very fluffy also. So it has got a very, very high surface area. So this can be very effectively utilized as anti-sagging agent, and it has got fantastic hydrophobic characteristics also. So wherever you want to have the foolproof hydrophobic, that is waterproofing is required, you can think of using this fumed silica, and it is a great rheological modifier also. So as I already mentioned, so let me talk about the major differences between these types of silica based on the origin also. For example, silica sand, when you look at the origin, it is a natural one. So natural quartz. And when you look at the microsilica and the silica fume, it is a byproduct of a silicon metal smelting. So when you smelt the silicon metal, it comes as a byproduct. So that is very effectively utilized in the industries. Then precipitated silica is that is, it is actually precipitated from sodium silicate. Okay, it is totally a synthetic product. Then, when you look at the fumed silica, it is obtained from flame hydrolysis of silicon tetrachloride, and that is why you are able to get the very, very fine product that is in the nanoscale. Then, let me talk about the structure of a silica sand. So, this is crystalline, whereas starting from micro silica or silica fume, precipitated silica, and fumed silica. These are all amorphous only. Amorphous means non-crystalline. Then the reactivity aspect can be discussed here. Usually, silica sand is inert, chemically inert. It means that is it doesn't react with any other uh, acid or bases or any other chemical reagent, and it reacts with the calcium hydroxide. So it is called pozzolanic, means that is it is capable of reacting with calcium hydroxide, and that is why it is very effectively utilized in the uh, architectural or cementitious products. Then, so this is one of the best, I would say, the raw materials for the construction chemicals. Then it is chemically inert, which one? The precipitated silica, whereas the microsilica or silica fume is capable of reacting with the calcium hydroxide. So we can think of using this effectively in waterproof coatings and particularly in cementitious coatings also. Then The fumed silica is no doubt it is chemically inert, but it has got reactivity physically. So it is subjected to that is a physical modification. So now let me explain about the surface area. So one thing you must understand, when the particle size is reduced, the surface area increases and thereby the wettability, whether it is a wettable with water or wettable with any other solvent, it is a great challenge to grind such type of silica. So the surface area is less than 1 meter square per gram, whereas microsilica 15 to 25 square meter per gram. And precipitated silica, you just think about that, the range is 150 to 250. And when you look at the fumed silica, its surface area is unimaginably very high. That is in the range between 200 and 400. Then, when we think about the usage, that is how much percentage is used in the mix of any products associated with the construction chemicals. So here, silica sand, it is a bulk filler, as we know, because it is taken almost a 20 to 50 percentage. Whereas microsilica and the silica fumes are used uh, up to 10%. It is added as a performance additive. Whereas in the case of a precipitated silica, it is a functional additive. So it takes an important role in coatings and paintings. Then it is added in a less percentage from 0.5 to 3% only. So these are all used as additive. Whereas fumed silica is a rheological controller and it is a very good hydrophobic agent also. So naturally, its a percentage use in this coating formulations is very, very less. Then summary of application. So silica sand, as you know, from 200 to 300 mesh for structural bulk and abrasion resistance in screeds and mortars and waterproof coatings. Waterproof coatings, the silica sand is used. Then micro silica and the silica fumes are used that is in waterproofing and chemical resistance, cementitious coating systems. Then precipitated silica, they control glass, and that is why it is used as a that is a matting agent and is used as a thickener also. It is a very good anti-settling. It improves the anti-settling characteristics of paints and coatings. Then, when we explain about the fumed silica, that is, it is not at all requested but included. That is, fumed silica. Fumed silica is high-end rheology modifier and in coatings, particularly in adhesive and sealants. Thank you very much for watching this technical series. And if you've got any doubt, you can ask me in the comments column.